Hi guys, welcome in this video, and today we're going to talk about the stack, more specifically about stack frames, function prologue and epilogue, and some of the calling conventions. First of all, I just want to do a quick recap about the stack. The stack is a LIFO data structure. It's a last in, first out data structure. It means that the first argument pushed into the stack will be the last one to be popped. The stack is simply an area in the random access memory. Also, the stack grows down to the lower memory addresses. It means that the top of the stack will have a higher address than the bottom of the stack. So, what is a stack frame then? A stack frame is just a space on the stack used to store a return address, local variables, and arguments. Yeah, you probably guessed it. When a function is called, a stack frame is created for this function. Second of all, there is something else we need to talk about before digging into stack frames. As I said earlier, in a stack frame, there are some functions parameters or arguments. According to the calling conventions, in a 64-bit computer, the first argument goes into RDI, the second one goes into RSI, the third one is moved into RDX, the fourth one is moved into RCX, the fifth one into R8D, and the sixth one into R9D. And if the function takes more than 6 function parameters or arguments, the arguments are pushed into the stack frame of the current function. Nice! So we will see how all of that works in memory thanks to this simple C program here. So first of all, we have a main function where we initialize 3 integer variables and we declare a buffer array of 100 bytes. Then we call the function1 function, which takes as an argument an integer. In this function1 function, we declare a buffer array of 30 bytes, we initialize 2 integer variables, and we add 2 to the arguments that we passed in. Then we initialize a pointer, which will hold the address of C, and we call the function2 function, which takes as an argument a pointer. And in this function2 function, we will dereference this pointer and add 1 to the values the pointer is pointing to. Then we declare 8 integer and we initialize them here. After that, we call the function3 function, which takes as arguments 8 integers variables. And in this function3 function, we add 12 to the variable g and add 1 to the variable h. So now let's step into it. First of all, you need to know that when a program starts, the first function called is not the main function. There are some other functions before the main function, okay? When a function is called in general, and in this case when main was called, a call save register or IP, or return address, was pushed into the stack. In this case here, this is the return address. And this return address is pointing to the libc start main function, more specifically to the instruction move edi eax. Okay, that's cool. Let's talk about the stack pointer now. The stack pointer will always point to the top of the stack, and in this case, as you can see, the stack pointer is pointing to the top of the stack, which is 3D8. And 3D8 is pointing to the return address here, which is pointing to this instruction here. Okay, cool. Now, as I said earlier, when a function is called, a stack frame is created for it. So when main was called, the stack frame was created for the main function. And we can see our stack frame here. You can know more about your stack frame with the info frame command here, and it says that at stack level 0 there is the stack frame of main, and that the frame starts at the address of 3E0, which is here. It says also that RIP is pointing to this address, which is this current instruction, and it says also that the saved RIP is this address, which was pushed into the stack when main was called. It says also that arguments and local variables are starting at 3D0 and that the previous frame stack pointer was at 3E0. It's totally normal because before that main gets called, the stack pointer was not pointing to 38 because the return address wasn't in the stack at this moment. Okay, the stack pointer was pointing to 3E0, and when main was called, this address was get pushed into the stack, so the stack pointer is no longer pointing to 3E0, but it's pointing to 3D8. And it says so that the saved RIP that's 3D8 because stack pointer is pointing to 3D8, which is pointing to their return address here. Okay, that's cool. Now let's talk about the function Prologue. So these three instructions here is called the function Prologue. So the first instruction is push RBP. What it will do? So you would say it's gonna simply push the base pointer to the stack. Okay, that's cool, but why it's gonna push the base pointer into the stack? It does that because it needs to store the base pointer into the stack to restore it later. You need to restore the base pointer into the stack to pop it later to get back to the previous stack frame. We're gonna see that later. And let's do this instruction. So it pushed the base pointer into the stack. The base pointer had a value of arg0, so arg0 was pushed into the stack. So the stack pointer is no longer pointing to 3D8, but it's pointing to the top of the stack, which is 3D0 here. Okay, that's cool. Then we have move RBP RSP. So it's going to move the stack pointer into the base pointer. So the base pointer will be able to point to the top of the stack. Okay, so let's do it. As you can see, the base pointer and stack pointer both are pointing to the top of the stack, which is 3D0. And then we have sub RSP OX70. So first of all, OX70 is 112 bytes. And if you remember correctly, the stack goes down to the lower memory address. So it means that if you subtract from the stack pointer 112 bytes, for example, it means that the stack will grow. Why? It does that. I mean, remember, you need to allocate memory for our local variables and arguments. So as you can see here, we have 3 integers, so 12 bytes, and we have our buffer array here of 100 bytes. So it allocates 112 bytes for our 3 local variables here, our integers here, and our buffer array here. Okay, so let's do it. Okay, so you need to know that local variables and arguments are allocated below the base pointer but above the stack pointer. So all of this memory is allocated for our integers here and our buffer array. Okay, that's really cool. So we will do that later, sorry, but as you can see, we can store now our local variables and arguments. So it's going to initialize the variable a here, so it's going to move OXC, which is 12, in RBP minus 4. So the local variables and arguments are starting whereas the base pointer is pointing to. And you need to know also that there is a frame pointer. So what is the address the frame pointer is pointing to? 3D0. Hey, 3D0. Yeah, so the frame pointer is pointing to the same address as the base pointer, which is 3D0 in this case. Okay, that's cool. So this is our stack frame here. So here it's going to initialize A. So it's going to move OXC into RBP minus 4. So as you can see, we have OXC here. Then it's going to move into RBP minus 8 because it's integer, so 4 bytes, OX1P2, which is 434. And then it's going to move in the memory location pointing to by RBP minus OXC. Sorry, this is what I needed to say earlier. So it's going to move OXC in the memory location pointed to by RBP minus OXC. And it used a D word pointer here. It specifies the size because double word is 4 bytes and this an integer is 4 bytes. Will only use 4 bytes of space here. Okay, that's cool. Okay, then you need to call the function1 function, okay? To call it, you need to have arguments. As I said earlier, arguments go to RDI, RSI, RDX, RCX, R9D, and R8D. So the first arguments go into RDI, okay? So here it's going to move the memory location pointed to by EAX, which is here, OXC. So it's going to move 12 into EAX. As you can see, REX contains OXC now, and it's going to move what there is in REX, because REX is not used for arguments. It's going to move OXC, what there is in OXC into RDI. So as you can see, RDI is used as an argument, which is OXC here. And the function1 function will be called with the OXC argument here. Okay, that's cool. So we call the main function and look the stack right now, and we call the function1 function. Okay, so as you can see, a call is saved register or IP, a return address was pushed into the stack. So the stack pointer is no longer pointing to 3C0, but the stack pointer is now pointing to 358. We can know more about our stack frame here. And as you can see here, the stack frame of main is no longer at stack level 0, but at stack level 1. And here we have the stack frame of the function1 function, okay? So it says that at stack over 0, there is the function1 stack frame, and the frame starts at 360, which is here. The RIP is pointing to C9 here, which is the current instruction push RBP, or function Prologue here. And it says that save RIP was pushed into the stack, which is here. Arguments and local variables are starting at 350. And it says that the previous frame stack pointer was pointing to 360. But as you can see, stack pointer is pointing to 360 when function1 is called. The stack pointer is no longer pointing to 360, but to 358 here. That's really cool. So we are at the function Prologue here. So this is the stack frame of main. Stack frame of main doesn't contain this return address here. This was a stack frame of main which have local variables and the return address here, but not arguments. We will see that later. And here we are at the function Prologue here. So it's going to push the base pointer. As you can see, it pushed the address of the base pointer here. Push the address the base pointer is pointing to the top of the stack, sorry. It's normal because it pushed it. It does that to restore it later. So if you remember correctly, we're gonna move the base pointer, sorry, the stack pointer to the base pointer. So the base pointer will no longer pointing to 3D0, but to 350. So to restore the base pointer, to get back to the main function, we need to store it into the stack and then pop it into RBP. We're gonna see that later, but it's gonna be really cool, okay? And then it's gonna move stack pointer to the base pointer. So the base pointer is pointing to the top of the stack, so as you can see here. And then it's gonna subtract from the stack pointer OX40, which is, let's see that, which is 64 bytes. Okay, that's cool. So as you remember, stack goes down, does that to allocate memory for our local variables and arguments, because it's gonna initialize a buffer right here of 30 bytes, initialize A and B, so two integer, which is in total 8 bytes. Then it's gonna add 2 to the C, we're gonna initialize a pointer, etc. So you need to allocate space for our local variables and arguments. Okay, let's go. RBP. So it's gonna move to RBP minus OX34 EDI. It's gonna move our current argument which is in RDI into RBP minus OX34, sorry. So as you can see, there is OXC in the stack frame of the function1 function here, okay? Then it's gonna move into RBP minus 4 OX1992. It's gonna initialize the variable A, and then it's gonna initialize the variable B into RBP minus 8, and to the memory location pointed to by RBP minus 8, but now I think you understand. Then it's gonna move into EAX, the memory location pointed to by RBP minus 4, which is OXC, as you remember. And then it's gonna add to EAX 2, because I said I want to add 2 to my C variable here. So I'm gonna add 2 to EAX here, as you can see, OXE. So OXE into REX, sorry. And then it's gonna move into RBP minus 4 where there is an EAX. So it's gonna replace the OXC here. It's gonna replace it by OXE here. As you can see, there is OXC in the stack frame of the function1 stack frame. Sorry. Then it's gonna load the effective address of RBP minus 34 into RAX. It's gonna load the effective address of the memory location pointed to by RBP minus 34 into RAX. So it's gonna load the address of it. As you can see, we have an address here. It does that to initialize our pointer, because I said I want to have a pointer which holds the address of C here. Initialize the pointer at RBP minus X10 and move RAX into memory location pointing to RBP minus X10, and it specifies the size here, keyword, sorry, it's gonna use forward of space, which is 8 bytes. And then it's gonna move into REX, memory location pointed to by RBP minus 10, which is our pointer, because we're gonna use that pointer as an argument for the function2 function, as you remember. So it's gonna move it into REX and then move it into RDI. So as you can see, RDI have the address contains in the pointer. So we call function2, and the stack frame is created here. So as you can see, the function1 is no longer at stack level 0, but at stack level 1. The main function is no longer at stack level 1, but at stack level 2. And we can see that function2 is at stack level 0. We can know more about our stack frame here. You can see that a return address here gets pushed into the stack. The stack pointer is no longer pointing to 310, but at 308. The stack frame starts at 310, and it says that it was called by the frame at 360, which is the stack frame of the function1 function. And say that argument was OXD here. Arguments and local variables are starting at 300, and as I said earlier, stack pointer was pointing to 310 before that this function gets called. Okay, cool. So we are at the function Prologue, so I'm gonna do what you know now. So I won't step into it. And it's gonna initialize a lot of variables. So it's gonna initialize our pointer first, which will be initialized in RBP minus OX28, sorry. So it's gonna move RDI into the memory location pointed to by RBP minus OX28, and it's gonna initialize. It's gonna dereference. So it's gonna move into REX, the memory location pointed to by RBP minus OX28. So it's gonna move the pointer into REX. Okay. As you can see, REX contains our pointer here. Then it's gonna dereference this pointer. It's gonna move into EAX, a memory location pointed to by REX. So it's gonna move OXE into EAX. As you can see, it dereferences the pointer. So REX has OXE now, and it's gonna load the effective address in EDX of the memory location pointed to by RAX plus OX1. So you're gonna add 1 to the address that we are dereferencing. So to the value, sorry. So we dereference this address and we add 1 to the value. And we load all of that in EDX. As you can see, in EDX we have OXF here. And then it's gonna move in RAX, sorry, is a pointer again. It's gonna dereference RAX and move what there is in EDX. So it's gonna move EDX into the memory location pointed to by RAX. So it's gonna dereference RAX and move EDX. As you can see, RAX is pointing to this address, which is our pointer. The address contains a pointer, and here we have OXF here. Okay, that's cool. So now our pointer exists now, so that's cool. So this is our pointer here. Stack pointer is pointing to our pointer, and it's gonna initialize all of our variables here. Really cool. Okay, now this is interesting. As I said earlier, if you have more than 6 arguments will be pushed into the stack. Okay, that's cool. So I say that the last arguments will be pushed into the stack. So what will be pushed in R9D? Look at this. Okay. Here we are in the function2 function. So f, which is 6, will be pushed into R9D here, which is at RBP minus OX18, sorry, R9D. So now R90 contain OX6, as I said. Then in R8D, it's gonna move E, which is equal to 5. As you can see here, R8, OX5. Then it's gonna move into ECX D, which is equal to 4. As you can see, RCX here, OX4. Then it's gonna move into EDX C, which is equal to 3, into ESI B, which is equal to 2, and then into EAX is going to move the first argument, which is E equal to 1. It's going to move into EAX. You're going to see why next. Okay, then it's going to move into EDI, the memory location pointed to by RBP minus OX20, which is our G here, which is equal to OX7. Sorry. As you can see, RDI contains, sorry, what did I say? Sorry, it's the last argument. So it's H. H is gonna be pushed into the stack because it's the last argument. So it's gonna be pushed first. Okay, so this is H, sorry, RBP minus OX20. H, which is equal to 8, moved into RDI, and then RDI is pushed into the stack. So as you can see, RDI was pushed into the stack. So now the stack frame contains our return address, local variables, and now our argument, an argument here. And then it's gonna move into EDI RBP minus OX1C, which is G now, which is pointing to OX7, sorry. G contains value of OX7, as you can see, and then it's gonna be pushed into the stack. So the stack frame here has 2 arguments for our next function. And then it's gonna move into EDI is the first argument that we move into RAX, which is OX1 into EDI. That's really cool. So we call function 3. There is a bug here because we use more than 6 arguments. So we call the function 3. Looks like we have a red zone here. Sorry. So we are at the function Prologue here, and we have the 2 instructions: push RBP, move RBP, RSP. So we're gonna execute these 2 instructions, And you might be wondering why there is no sub RSP and number here, whereas we are initializing 6 variables. It's because there is a red zone below our stack pointer, our stack frame. A red zone is a fixed size area in memory of 128 bytes long, currently below the current stack frame or the stack pointer. And it's commonly used when there is a leaf function. A leaf function is a function that don't call other functions, and in this case function 3 isn't calling any function or other functions here. And it's used to allocate additional memory, and it reserves one instruction because it doesn't need to move the stack pointer. In this case, as you can see, we don't have any sub RSP and number, but it's gonna initialize these 6 variables into the red zone. Okay, so we're gonna initialize the 6 variables here. Yeah, and we're gonna examine a 6 variable into the red zone. So yeah, 28. Okay. So as you can see here, there is 6 variables here. 1, 2, 3, 4, 5, 6. So A, B, C, D, and E into our red zone without moving the stack pointer. Okay, so that it's a cool feature used when there is a leaf function. Okay. And you need to know also that this red zone is relative to the stack pointer. Okay, so a red zone will be always, it's gonna be always 128 bytes below the stack pointer. So then we're gonna add to the memory location Function2 by RBP plus OX10 OXC. As you can see here, and then OX1 to OX8. So we have OX9 now. Then it's going to do a no operation instruction, and then we are at the function Epilogue. So in this case we have pop RBP here because we, as you know, we push the base pointer to the stack, so you need to restore it to get back to the previous stack frame because we are getting back to the Function2 stack frame. And we pop RBP to put the last address of the base pointer. So as you can see, this is where the base pointer was pointing to before that we call the Function3 stack frame. And then it's going to move this address into the base pointer. So the base pointer will no longer pointing to 2v8 but to 300 here. And then we're gonna do a pop RIP, so we get back to the Function2 stack frame. Yeah. So as you can see, we get back to the Function2 stack frame. So the pop RBP moves the last address of the base pointer into the base pointer. So the base pointer is no longer pointing to 2v8 but to 300. So, and then there is a read instruction, so the pop RIP, and we get back to the Function2 stack frame. So I hope you understand. And then we have add RSP extend. What is that? So we need to delete the temporary function parameters. So here we have the 13 and 9 here, and these were the arguments that we used to call the Function3 stack frame here. So it was a G and H that we modify thanks to the Function3 stack frame. And so we are in the Function2 stack frame, and we don't need these two arguments anymore. So to delete it, we simply do add RSP extend. So the stack pointer will no longer point to C8 but to 2D8 here. Okay, so as you can see, we are in a fresh stack frame, if we can say that. Here we have our pointer, as you remember, etc., our variables. Then we have a no operation instruction. So here we are at a function epilogue 2. So we are not at a pop RBP, but the leave instruction is in fact, we can say that, two operations. The leave instruction is a move RSP RBP, so it's gonna do, you can say that, the contrary of the function Prologue. It's gonna do the opposite of it. And then it's gonna do a pop RBP, and you write how. See, write instruction that we have here. So basically, the leave instruction is a move RSP RBP, so it's going to move the base pointer into the stack pointer. So the stack pointer will no longer pointing to 2D8, but to 300. And then it's going to do a pop RBP. So it's going to pop this address into RBP, so the base pointer can get back to 350. And then we have the read instruction, so it's going to do a pop RIP, and we can fully get back to the Function1 stack frame. Okay, so we're going to perform it. So we're going to execute the instruction leave. So as you can see, this is our stack. We do the leave. So RSP is pointing to the same address as the base pointer. So it's 300. Then we have the pop RBP. So 350 is popped into RBP. So RBP is now pointing to 350, and stack pointer is now pointing to 308. And we can do now the read instruction, so the pop RIP, and we fully get back to the Function1 stack frame. So as you can see, this is really cool. I really love how stack works, to be honest. And we have a no operation instruction again, and then a leave. So the leave is a move, or stack, it's going to move the base pointer into stack pointer. It's going to pop RP, and then we're going to fully get back to stack frame of main. So then we have a move EAX0. It's like return 0 or something like that. And then we use leave instruction. So this is how our stack looks like before that we do all of these operations here. If you remember, when we were in the main function, before that the stack frame of main is created, our stack was like that, and the return address was pointing to the ellipsis start main, and now we can do a pop RIP and get back to the ellipsis start main function.